A sub n converges. Done. Okay, pause. Take a look at that question. Okay, try it yourself. And here we go. First thing is I'm going to write this out. Lord knows I'm already freaking out because I've got a sign. So let's write this out. Plug in 1, I get sine of pi over 2 over 1 factorial plus sine of 2 pi over 2, which is pi over 2 factorial, plus sine of, plug in 3, I get 3 halves pi over 3 factorial plus dot dot dot. I'm writing this out because I want to see what the heck's going on. And of course, if these values, each one of them gets bigger, I can conclude it diverges, and I can do that by the nth test. But what I get is the following. Now, remember I'm doing trig, so that point there is 1, 0. This point here is 0, 1. Over here I've got negative 1, 0, and so forth. So let's just, and this one down here is 0, negative 1. So I'm going by half pi. So the first one, sine is the y value, it's 1 over 1 factorial, which is 1, plus sine of pi is negative 1, right here, negative 1 over 2 factorial, which is 2 times 1 is 2, plus sine of 3 pi over 2 is down here, negative 1. Oh. Wow, I just totally messed that one up. Geez. Sine of pi over 2 is 1. Sine of pi is 0. My bad. Plus sine of 3 pi over 2 is negative 1. I was looking at the wrong values here. It should be looking at the y's. So negative 1 over 3 factorial is 3 times 2 times 1, which is 6, plus the next term, I don't have it written here, but it's going to be 4 over 2 pi, sine of 4 pi over 2, which is 2 pi, which is 0 again. So this next one would be 0, plus I'm going to try the next one just because I'm going to wind up over here, which is positive 1 over, let's see what number I had plugged in, 5 factorial, 5 factorial, plus, okay, so let's see what I've got. Let's reduce this. 1 minus 1/6, I'm getting rid of the 0 terms, plus 1 over 5 factorial. I'm kind of scared of that, so I'm not going to write it. The next term would be minus something, and so right away I'm thinking it's alternating series. Now it didn't show that. I don't see negative 1 to the n, so this part right here is alternating. Cosine curve will do the same thing. It'll alternate, so you just have to plug in values and check it out. Cosine curve is a lot easier. You'll see that. Sine curve has these zeros, which kind of interrupt my process. But I do see that each term decreases. I also can see it's not geometric. But the key tip-off is alternating. So I'm looking at the alternating. Does it alternate? Yes. Check. 2. Does it decrease? Does the absolute value of each one of these go down? Yes. So the only thing left for me to do now is take the nth test. And if the nth test, the third thing is I need the limit as n approaches infinity of the a sub n term. I need it to equal 0. If it doesn't, I have to conclude it diverges. Let's check it out. Here we go. So I'm going to take the limit of the a sub n term. I'm not going to write it out, but here's your a sub n term right here. Now when I take the limit of that, the top, the sine piece, Sine, no matter what value I'm plugging in, is alternating between -1 and 1. It's got to be somewhere in between there. It's got to be a restricted value. It has to be a value between -1 and 1. The bottom is n factorial. That's approaching infinity. So you've got a number, some number between -1 divided by infinity, which concludes as 0. I can also do this by L'Hopital's rule, but the whole n factorial part is a problem. But it doesn't really matter. I've concluded that the nth term is equal to 0. So by the alternating series, I've concluded all three pieces are satisfactory. So I can make my conclusion now. Since all three are satisfied, therefore, by alternating series test, I have converged. You saw the one before, the previous one that was alternating, it was divergent. That's because not all three tests were satisfied. Okay, pause. This next one, just a hint to you, notice that it has an X in it. If it has an X in it, then I need to find a range for which it converges, an interval of convergence, if it has one. So pause and try it yourself. And now I'll begin working it out. So the first thing is I'm going to plug it in. I'm hoping this is geometric, because if it's geometric, the interval of convergence is got to be between the R has to be between -1 and 1. So I'm going to plug in 1 and I get 3x minus 1 over 1 plus 3x minus 1 square over 2 plus 3x minus 1 over 3. Now if I check this out, the top is fine. It's the constant multiplier of 3x minus 1, but the bottom is not a constant multiplier. So this is not geo, which means I need an R. There has to be an R value for this x. So what I'm going to do is do the ratio test to create a figmentary R. So ratio test. Limit as n approaches infinity of. Now what I'm going to do is I'm going to take the nth term and I'm going to put the a sub n plus 1 term. So I'm going to take out these n's and replace them with n plus 1. So 3x minus 1 to the n plus 1 over n plus 1 divided by the a sub n term. This is the a sub n term here, but instead of dividing by that, I'm going to multiply by a reciprocal. Okay, now I'm going to start putting the pieces together. This piece and this piece correspond, and these two have the 3x minus 1 term. So I'm going to rewrite this so I can visualize it better and maybe reduce. So I've got n over n plus 1 times 3x minus 1. Sorry about the interruption. My wife just got home and the dog's going to bark. 3x minus 1 to the n. So I've got everything lined up. Now I'm going to take the limit, and I can take the limit of both these pieces separately. This part, L'Hopital's rule is going to apply. Get infinity over infinity, which is 1. Well, infinity over infinity, which is L'Hopital's rule. Derivative of the top and the bottom is 1. So 1 times this guy. This term here, I've got one more 3x minus 1 at the top than I do at the bottom. Or I have the same base, I can subtract exponents. N plus 1 subtract n is 1. So I get 3x minus 1 to the 1. So there you go. There's my figmentary R. So if I want to create a find out where this converges, I know it's got to converge when my R is between these two values. Add 1, multiply by 3, or divide by 3, okay, which gives me those two values. Now this is the interval of convergence. However, I'm not quite done, because basically these two n values could converge as well. So I'm going to check those in a second and create their own little two tests. But before I do that, I want to remind you that the radius of convergence is like a diameter. The diameter here is 2/3. The distance between these two is 2/3. So half of that is 1/3. My radius is 1/3. Now let's do a quick check on the two n values. What I'm going to do is I'm going to plug in x is 0 and x is 2/3 into that a sub n term at the top. So if I take the original function, the original a sub n, and I plug in 0, I get 3 times 0, subtract 1 to the n over n, which gives me -1 to the n over n. So there's one function to check the end at 0. Now I want to plug in 2/3 into the original function. 3 times 2/3, subtract 1 to the n over n. 3 times 2 divided by 3 is 2, subtract 1 is 1, so I get 1 to the n over n, which is 1 over n. Now all I'm doing here is, right now we have the interval of convergence here, but what we want to see is to see if these two n values are also included in the interval of convergence. This one is going to alternate. See that -1 to the n? So plug in 1, I get this. Plug in 2, I get that. Plug in 3, I get that. Okay, so right now I can see that it's alternating. Check. 2. I'm going to check to see if it's decreasing. -1, or I'm sorry, 1, half, 1/3, yes, decreasing. 3. Now I need to take the limit as n approaches infinity of the a sub n term, which this is my new a sub n term. Okay, so I get at the top, I get 1 or -1 at the top, so I've got this number at the top divided by infinity, which is 0. That's what I needed it to do. It does go to 0. Therefore, this part converges. Meaning that x equals 0 is in the interval. Now I'm going to check the other end. The other end is this one. It's 1 over n. I got a p equals 1. If p equals 1, let me see if I can find the page where it says it. Well, if p, the p series, so by p series, my p is less than or equal to 1, therefore diverges. So that's not in my interval of convergence. So final conclusion is, where does this thing converge? It converges on the interval from 0 to 2/3. Oops. 2/3, but now I have to include the 0 because we've concluded that at 0 it does converge. So this is the interval of convergence. Okay, I will post up a set of questions for you to work on of your own. I'll post up the work like I always do. And gosh, I wish I could be in class to hear your voices.